Foundations of Amateur Radio. You've always been taught that VHF communications are line of sight, and that the height of your antenna determines how far your 2-meter communication might go. So if I tell you that last week I spoke with a station that was 300 kilometers away on the 2-meter band, you might be forgiven in thinking that I had managed to climb up most of the side of Mount Everest to around 7 kilometers, so I could make my line of sight communications 300 kilometers away. I'll give you a hint. I was at my home. My house isn't on the side of Mount Everest, and we are both using normal gear. Nothing crazy, no amplifiers, no glitzy antennas, just the basics. So what's going on? There's a phenomenon called tropospheric ducting that comes and goes if conditions are right. Allows you to extend your line of sight communications to distances far beyond your imagination. So what is this thing and how does it work? First of all, this is something related to the lowest part of the atmosphere called the troposphere. It has nothing to do with the ionosphere, which we know and love, and use regularly to make long-distance communications on the HF bands. The ionosphere starts somewhere about 60 kilometers up. The troposphere stops at about 12 kilometers. Tropospheric ducting happens much lower down, at the most around 3 kilometers up, but normally between 500 meters to 1500 meters. In essence, a tropospheric duct is a layer of warm air trapped between two layers of colder air that acts as a tunnel for radio signals. These kinds of layers aren't caused by weather as such, but by climate conditions such as weather fronts. Normally, as you go up into the atmosphere, the temperature drops. The rate is around 6 degrees centigrade per kilometer. Without going into the fascinating science behind it, think about it as a phenomenon where you'll find different types of layers of air over the top of each other, each with their own density and temperature. When the conditions are just right, you get a tunneling effect that allows you to make some very long-distance communications. There's reports of signals travelling over 4,000 kilometers, and if conditions are right, you might be able to hear such long-distance signals on your household FM radio. One aspect that you might not have considered is that the thickness of the sandwiched warm layer determines which frequencies can travel along this so-called tunnel. If the thickness is 15 meters, you can expect to hear 11 gigahertz signals. 90 meter thickness gives you 400 megahertz propagation, and 180 meter thickness gives your 140 megahertz signals a path to travel. If you manage to find a layer that's 430 meters thick, you might even manage to make contact using 29 megahertz, using a tropospheric duct. Now, you might be forgiven in thinking that this is all voodoo and unpredictable, but it turns out there are plenty of things that you can use to observe that conditions might be right. If you have local fog or smog trapped over your station, you might be able to take advantage of this phenomenon. It's not that the smog or fog is causing the duct, it's that they happen to occur at the same time as the ducts are created. If you see a sharp layer in the sky, then turn on your radio and have a gander. I won't guarantee success, and you can look online for William Hepburn's worldwide tropospheric ducting forecast, but you really don't need that to get started. Tropospheric ducting happens all over the planet, and it might be happening right now. I'm Ono, Victor Kilo 6, Foxtrot Lima Alpha Bravo.